Okay, this is the beginning of the recording that covers Chapter 5 from the latest test when you want to do corrections. Chapter 5 was polynomials, adding, subtracting, multiplying, and dividing them. So I'm going to start on question number 23 here. And the question, you can look on your paper on number 23, but I'm going to put x squared minus 5x plus 2 as the divisor, and the dividend is 5x to the fourth. So we go back. 5x to the fourth minus 20x to the third minus 17x squared plus 23x and then minus 14. I just got to be really careful when I do this. And so the first thing is I've got my columns, and so here's my columns of things. Of my x squareds, my x's, and my constants. Okay, so there it is there. So let's go ahead and go and do this. So I need to know x squared times what gives me 5x to the fourth. Well, that's going to be 5x squared that's 5x squared, so that gives me 5x to the fourth. Now I'm going to do 5x squared times negative 5x. So that's negative 25x to the third. I'm going to go 5x squared times 2. So that's plus 10x squared. Now I'm going to subtract. So I'm going to subtract here. And essentially I'm changing all the signs inside. If I want to turn it to adding, it's up to you, but I'm going to do it like this. 5x to the fourth minus 5x to the fourth is 0. Negative 20 minus negative 25 is plus 5x to the third. Negative 17 minus 10 is negative 27x squared. Now bring that sucker down to 23x's and go through the same process. So I need to ask myself, x squared times what gives me 5x cubed? And it looks like 5x. So I'm going to write 5x, whoops. I'm going to write 5x here. Okay, so again I'm going to go back and do this times that. So that's 5x cubed. Made a mistake. Then I'm going to go 5x times negative 5x, that's negative 25x squared, and 5x times 2 is 10x. I'm going to subtract again. So all those signs inside flip if I want to add. Okay, so I'm going to get these cancel out. So 5x cubed minus 5x cubed, negative 27 minus 25. So that's right here. People sort of get lost in the busyness of all this. Negative 27 minus 25 is actually plus 25, so that's negative 2x squareds. And then I've got 23x's plus 10x's. It's 33x's. Now I'm going to bring this down. Subtract 14. Now I go through the same process. I'm going to look at this one right here. So x squared, so it's going to be negative 2, Whoops, I got the wrong thing going there. So I get negative 2x squared. Negative 2 times negative 5 is plus 10x. I already found a mistake here. You may have found it earlier. 23 minus 10 is not 33, it's 13. And then I've got negative 2 times 2 is negative 4. I'm going to have to subtract. I'm going to subtract here. So that turns to adding and you get 0. 13 minus 10 is 3x. Negative 14 plus 4 is negative 10. So I'm going to add to my answer 3x minus 10. That's my remainder, and I'm going to divide by my divisor, x squared minus 5x plus 2. So for question 24, they ask you to do synthetic division to do this, and we know we can do synthetic division because this has got a 1 here and this got a 1 to the power here. So we're okay with doing synthetic division. And so when I do it, I'm going to set it up and I'm going to check. I've got x cubes, so again, I've got x cubes, x squareds, x to the firsts, and x to the zeros right here. So in a sense, I've got them in descending order. I don't have any skips, so I'm in good shape. So I can write just the coefficients. I'm going to write 2, negative 5, negative 11, and positive 22. I'm going to make my... Okay, and so now this number we want, it's x, the opposite sign of that, so that's a positive 3. And we subtract, we add going down. 2 plus 0 is 2. And we multiply going this way times 3. So that's a 6. Now I add going down again. So that's negative 1. Excuse me, positive 1. Multiply by 3. So I get positive 3. Add going down. It's negative 8. Multiply by 3. And you get negative 24. So when you add those together, that gives me a remainder of, negative 2. So I need to interpret this. So this is really x to the 0, so this is a constant. This is going to be x to the first. This is x to the second, and that makes sense. X to the first and x to the third. 3 minus 1 is 2, so yes, this makes sense that that's a 2x squared. So we just write our answer down. Here's our remainder right here. There's the remainder. Okay, and I'll just write the correct answer down below. So it was actually 2x squared plus x minus 8 plus negative 2 over x minus 3. So in number 25, they want you to divide 2x to the fifth minus 3x to the third minus 3x to the first plus k. You want to divide it by x minus 3. I guess I should put parentheses on this. They want you to divide it by x, all by x minus 3. Now, we got a bit of a problem here because they're skipping some powers. So the first thing we need to realize, and so we don't mess up, there's actually plus 0x to the fourths fitting in right here. And we got plus 0x squared fitting in here. So, and we want to do dividing evenly. Dividing evenly means the remainder has to be equal to 0. So if I write this out, I'm going to have 2, 0, negative 3, 0, negative 35, and then I'm going to end up with k. I've got my synthetic division, and we want this to be 0. So when I look at it at the end, this here is going to be my equation. K plus question mark has to equal 0. So let's go through it here. And then they say that we're going with the opposite of negative 3, which is 3. So again, add down. That's 2. 3 times 2 is 6. 6. 0 plus 6 is 6. 3 times 6 is 18. 3 times 18, excuse me, negative 3 plus 18 is 15. 3 times 15 is 45. I'm going to add down again. 0 plus 45 is 45. 3 times 45 is 135. When I add down here, I get 100. So now I'm going to get 300 here. So remember, this is my equation I got to figure out. There's a plus sign here and an equal sign here. So I just need to solve that equation. K plus 300 equals 0. Turns out K is negative 300. So in this one here, people get intimidated by it, but they want you to divide by x to the n plus 2. Now, some people got lucky and it worked with synthetic division, but technically you shouldn't risk doing synthetic division on this one, because this isn't really x to the first. It's really x to the 1n. Now, it happens to work. That's great, but you just got to be careful there when you do that. It tends to work. It will work with synthetic division on this one if you're careful. So, that said, let's go through it here. And a couple things you need to remember. X to the n times x to the 2n is actually x to the n plus 2n, which is x to the 3n. Okay, so that's important to know that. And using that will help us when we do this one right here, because x to the n times what is x to the 3n? Well, it's x to the 2n right here. But it turns out you actually want to have a 3 there, because you want to end up with a 3. Otherwise, we're going to end up with just x to the 3n. So here's the 3 in front. So now when I do this, and I go these two multiplied together, I'm going to get x to the 3, 3x to the 3n. And then when I go 3x to the 3n times 2, 3x to the 2n times 2 is 6x to the 2n. And that's going to be 10 minus 6 is 4x to the 2n. I'm going to bring this down, and we'll go back through it. And we're going to ask ourselves the question here. If I want to equal 4x to the 2n, if I divided that by x to the n, that would be 4x to the 2n minus n, which is 4x to the n. So that's what I'm going to need to multiply at the top. 4x to the n power. 4x to the n power times x to the n power, we already know, is 4x to the 2n, which is why we did it. And then 4 times 2 is 8x to the n. Now I'm going to again subtract. And that's going to give me 3 minus 8 is negative 5x to the n. And now I'm going to go through the same process, and that's going to be a minus 5 here. Negative 5 times x to the n is negative 5x to the n. Negative 5 times 2 is negative 10. Turns out when I subtract these, I get 0 and 0. So there's my answer at the top here. My answer is right here, at the top. Okay, here's number, I forgot to write the number down, it's number 27. Okay, 1/3 x minus 2 all to the 5th power. Now you can go ahead and start multiplying all these 5 sets of parentheses and of binomials and do that. It's going to be quite long and tedious. Or you can use the Pascal's triangle. Pascal's triangle says, looks like this, and you can continue the pattern. 1 plus 1 is 2. Then you start with another 1, and then 1 plus 2 is 3. 2 plus 1 is 3. And you continue on 1, 4, 6, 4, 1. Can't really see that one. That's a 1. That's a 1 right there. Okay? And then you continue on. And how far do you go? Well, you go till you get, change that color there, and the rows equals 5. Okay, well, how do you know the rows? Well, this is, the row is 0, 1, 2, 3, 4. We need one more row. So let's do that row in there. So that's 1, 5, 10, 10, 5, and 1. Now I had to squish it in there. So we want that row. And this is going to tell us our coefficients. That's our coefficients. So I know my coefficients are going to go 1, 5. Let's go backwards here. Leave some more space. 1, 5, 10, 10, 5, and 1. Now, you also have to check the signs. So I'm going to put the signs in red here. It turns out because this is a minus sign, the signs go positive, negative, positive, negative, positive, negative. So this is going to be negative, positive, negative, positive, negative. Okay, so we got that going. We got the signs. It doesn't really tell us what to do inside, but let's go through that here. And we're going to call this A. Since we already dealt with the signs, 2 is the B. So I'm going to have 1/3 x to the 5th, because that's the highest power. And then the next term is going to have a 1/3 x to the 4th power, one less. The next term is going to have 1/3, whoops, I forgot the x, to the 3rd power. And then 1/3 x squared, and then 1/3 x to the 1st, and if you like, 1/3 x to the 0. Now remember, 1/3 x to 0, anything to the 0 power except 0 is 1, so we don't really need this. This is a 1 here. We don't really need that. Okay? And just so you are aware, if you weren't already, 1/3 to the 5th is 1 over 243. 1/3 to the 4th is 1 over 81. And 1/3 to the 3rd is 1 over 27. So if you weren't seeing that, those are in there. And then, so we've got that part. Now we need another part here. I'm going to do it in a different color. I'll do it in green. We need the back part. We need the B part here. Well, that's going to be in the back here, it's 2 to the 0. Here it's 2 to the 1st. Here it's 2 to the 2nd. 2 to the 3rd. Whoops, I went backward. No, I just totally messed that up. we got to count backwards from there. So instead of going 0, we're actually going to start with 5. So that's supposed to be a 5, sorry. 5, 4, 3, 2. Now we want 2 to the first, and we want 2. Whoa, that's a big mess. It's hard to fit it in there. 2 to the 0. Remember, 2 to the 0 is 1. So I can go ahead and cancel this out. Okay, and I can just go ahead and solve this thing. So that's 1 times 243 x to the 5th. So okay, now most people don't write it like that. They'll go write it like this. They won't multiply by 1. They'll just go x to the 5th. Then they'll have a 2 and a 5. That's 10, and it's negative. They'll have an x to the 4th, and then they'll find out what 3 to the 4th is. And 1/3 to the 4th is over 81. Now here we have 2 to the 4th. That's 4, and 10. That's plus 40. Then they'll have an x to the 3rd divided by 3 to the 3rd on the bottom is 27. Then they'll go minus. This is 8 times 10 is minus 80, x squared. And then on the bottom, you'll have 9. Then we're going to have 2 to the 4th, which is 16 times 5 is 80. X is, you can say x to the first, but I'm just going to say x. And then 1/3 on the bottom. So 1/3. So, 3 on the bottom, which is multiplying by 1/3. And the last one is 2 to the 5th, which is 32. And there's a minus sign and a 1. So it's minus 32. There's your answer. Following Pascal's triangle, breaking it up into parts. There's your answer. Okay, this was a little bit tricky. They were in challenge problems, but we hadn't learned the Pascal's triangle yet. And one of the things is I wrote out the triangle here. Last slide it was a little squished in and it's hard to see it, but I wrote it out so you can see the pattern. And I wrote out one more row because last time we needed 5 rows. And this was, if this was row 0 here, then this is row 5. And we need, because this is a 6 here, we need n to equal 6. Okay? So that looks messy, but okay, we need n to equal 6 because of this power right there. Okay, so that's what we're looking at. Okay, the other thing we need to notice is the sign here is positive. That means there's no sign changes. So every answer is going to be positive. We're going to have positive signs here. So that makes our life one less thing to worry about negative signs. And we just got to get the order of the numbers right. So it's going to start with a 1. Okay, then we're going to use A. And that's right here. And this is B. So A is to the 6th power, and B is 3i to the 0 power. Now we're going to use the 6. We just used the 1. We're going to use the 6. So we're going to go plus 6. And now we're going to subtract 1 power. We're going to subtract 1 power from there, and we're going to add 1 power here. So subtract 1, add 1. Okay, so I'm going to do that now. So that's going to be 6 times 4 to the 5th, 3i to the 1st. So now we're going to do the 15 here. So now we're going to go plus 15, 4 to the 4th, and 3i squared. Now we're going to do the 20. 4 to the 5th, 3i to the 3rd. Okay, I'm going to run out of space, so I'm going to continue down below. I got the 15. 15 times 4. Totally messed this up. This is squared. And I just found a mistake over here. I went the wrong way. That should be, I'm counting backwards there. I do that sometimes. That should be a 3 there. So it goes 6, 5, 4, 3, 2. Okay, so and then I'm going to go, I'm counting up for the I, I'm counting up 3i to the 4th. And then we're going to go 6 times 4 to the 1st, 3i to the 5th. And the last one is plus 1. So we've got those. We're doing that last one there. And we're going 4 to the 0, 3i to the 6th. Make sure you understand that pattern. You need to pause it and just think about it. A couple of notes that people weren't remembering. I to the 1st is just I to the 2nd is -1. I to the 3rd is -I. And I to the 4th is 1. Okay, those are going to help us. Another thing is 4 to the 6th is 4,096. 4 to the 5th is just check it here. 1,024. 4 to the 3rd. Sorry, I should do 4 to the 4th. Is 256. 4 to the 3rd is 64. 4 squared is 16. And then you obviously know 4 to the 1st. A couple of other things to note. So I'm going to erase some other stuff here. We can do the same kind of counting with 3. 3 to the 6th, 3 to the 5th. So if you want to do that, that's fine. I'm going to erase some stuff here. So I have some room to write the 3's down. Okay, so there's that there. Okay, so for 3, 3 to the 1st is 3. 3 squared is 9. 3 to the 3rd is 27. 3 to the 4th is 81. 3 to the 5th is 243. And then 3 to the 6th. So 3 to the 6th is 729. It's hard to read. I'm sorry, I'm having to squish it in here. Try to make this 6 better. It's 729. So those numbers are going to help us. I kind of run out of space on this screen, so I'm going to go to the next screen. And you can verify the numbers, but I have worked these out. So I'm going to actually, just to give you a heads up, I'm going to change this number to 4,096. 3 to the 0 can go. 4 to the 0 can go. They're both 1. Okay. This number I changed to 1,024. This number is 256. 64. 16. And this is a 4. Okay, so I changed all those. I'll use a different color for the I numbers. Okay, this one is going to be 3 to the 6th, so that's 729 I to the 6th for that one there. This one here is going to be 243 I to the 5th. This one here is going to be 81 I to the fourth. And we're going to keep going through there. This one here, 3I to the third, is 27I to the third. 9I squared, and then go on from there. So now we got some interesting things happening because I already talked about the I's right here. The I's are right here, and so we can start changing some of those. So I'll use I'll use purple for that one. Okay, so this particular here is actually I squared. This is I squared, which is -1. So this whole thing, multiply it out. 729 -1. Okay, that'll be -729. This one here is going to be 6 times 4 times 243, and then this is actually I to the first power, because you can divide it by 4 and then the remainder is 1. This here is 1, so I can just actually ignore it, and I've got 15 times 16 times 81 for this term here. So I'm going to go through and do things like that. I to the third is just -I, and then I'm going to have a 27, and I'm going to have a 20 and a 64, and it's hard to see here. So I'm going to have them all simplified on the next page. So bear with me. So I used a calculator and I got all these numbers when I simplified it. And you notice how I'm changing all the I powers to either I, or if it's I squared, I'm using -1. If I'm using I to the third, it's -I. And if I'm using I to the fourth, it's 1. So that's what I get here. Now I just have to go through and add numbers. So in purple, I've got numbers. So this, and this all come together to get you -11753. Well, that didn't look very neat. And then in red, here's all your imaginary parts. And I'm writing it in standard form, so I'm going to do the I part second. And when I do that, I get -10296 I. So we're now finished doing Chapter 5, section of it.